Hello, everyone. Good day. So, for today's topic, I am going to discuss and differentiate descriptive and inferential statistics. So, I am your virtual instructor. I am Miss Aiko Adonis. So, welcome in this channel, Mathematics and Me. So before I continue discussing this topic, descriptive and inferential stat, I will also give you the important terms in this topic. So let's start with a variable. When we say variable, a variable is a characteristic or attribute that can assume different values. So these different values that can be assumed by a variable are what we call data. So data are the values that the variables can assume. It can be a measurement or an observation. Example of a measurement is the height of a building. And an example of observation is the percentage of old smokers who get ill because of smoking and many other observations. So, variables whose values are determined by chance are what we call random variables. Additionally, a variable is a collection of data values which form a dataset. And each value in the dataset is what we call data value or datum. Data can be used in different ways. The body of knowledge called statistics is sometimes divided into two main areas, depending on how the data are used. So the two main areas are number one, descriptive statistics, and number two, inferential statistics. So let's start with descriptive statistics. Descriptive statistics consist of collection, organization, summarization, and presentation of data. So as you can see in this picture, in descriptive stat, we have a population. So when we say population, it is consist of all the respondents or all the things that are considered in a study. So we have a population, and to get a sample from a population, we use a sampling procedure. So in descriptive statistics, you just select a sample from this population using a sampling procedure. And once you selected a sample, you conducted a study or a test in this sample. So you collected a data from the sample, organized the data, summarized the data, and then present the data in a form of graph, table, or chart. So in other words, when we say descriptive statistics, the statistician or the researcher only tries to describe a situation, or you just describe the attributes or the characteristics of the sample. So there is no conclusion, there is no prediction, or there is no inferences. There is only a description of the situation or a description of something that is under study. So let's have an example. Consider the national census conducted by our government every 5 years. So the result of this census give you the average age, income, and the other characteristics of the Philippine population. So to obtain this information, the Census Bureau must have some means to collect relevant data. So once the data are collected, the Bureau must organize and summarize them. So finally, the Bureau needs a means of presenting the data. So in some meaningful form, it can be in the form of chart, in the form of graph, or in the form of table. So in this example, the Bureau or the Census Bureau collected data, organized the data, summarized the data, and presented the data. It can be in the form of chart, graph, or table. So there is no prediction, there is no inferences, there is no conclusion. Only presentation or description of what is being studied. However, when we say inferential statistics consist of generalizing from the samples to populations, performing estimations and hypothesis tests, and determining the relationships among variables, and of course, making predictions. So again, let's look at this picture. So as you can see, we have again a population. So a group of people under study or a group of things under study. So given this population, you will perform a sampling procedure to select a sample that will highly represent the population. So after you selected a sample, you will conduct a study in this sample. So, dito papasok yung descriptive statistics. Just a description of the sample. You will just describe the characteristic and attributes of a sample. However, if you go beyond description, let's say, you give inferences or you generalize or you give prediction of the characteristics of the sample and you attribute it to the characteristic of the population, it is inferential statistics. Again, when we say inferential statistics, whatever the characteristic or the attributes that you found or you observe in a sample, we can also say that these characteristics or attributes are also the characteristics or attributes of the entire population. So you are already generalizing in this inferential statistics. You are making already a prediction out of the samples. Okay, so to understand it easily, when we say inferential statistics, the statistician tries to make inferences from samples to populations. So yung statistician or yung researcher, gumagawa na siya ng inferences or predictions or conclusions from samples to populations. And most often, inferential statistics uses probability sampling. So, examples of probability sampling are systematic sampling, multi-level sampling, cluster sampling, and the other sampling or probability sampling procedures. So I have here an example. You may be familiar with the concepts or probability through various forms of gambling. So if you play a card, dice, bingo, lotteries, you will win or lose according to the laws of probability. So here, it is important to distinguish between a sample and a population. So since it is important to distinguish between a sample and a population, let's define what is population and a sample. So I have also a picture. So a population is greater or larger than the sample because a sample is just a subset or a part of the population. So the members of the sample are taken from the members of the population. So when we say population, a population consists of all subjects. It can be human or otherwise that are being studied. However, when we say sample, a sample is a group of subjects selected from a population. Okay, so I have here a question for you. So why do you think it is possible or why is it not possible to use the entire population for statistical study? So what do you think are the reasons why it is not possible to use the entire population for statistical study? So you can comment your answer in the comment section so that we can see what are your ideas. Okay, so here is the answer to this question. So most of the time, due to the expense, time, size of population, medical concerns, and others, it is not possible to use the entire population for statistical study. Therefore, the researcher used only a sample because if you are going to use the entire population, it will take you more time. It will give you more expenses. And the size of population can cause um, malilito ka. It can cause some error in the gathering procedures or in the collection of data procedures or data collection process because you have so many or a lot of population or a lot of respondents. So it is hard for a researcher. Aside from it requires more time, it requires more money for expenses, it requires a very um, it requires more effort because of the size of population, and it is also hard in the part of the researcher. So that is the answer in this question. So next question. What is the importance of properly selecting a sample? Why do you think it is important to properly select a sample? So again, you can write your comment in the comment section below. So for my answer, if the subjects of a sample are properly selected, they possess same or similar characteristic as the subjects in the population, and the sample will highly represent the population. So in short or in simple answer, we select a sample it is important to select properly a sample so that the result of the study will be reliable because the sample that you have selected highly represent the population. Okay? Okay, so next, we have also what we called hypothesis testing. When we say hypothesis testing, it is a form of statistical inference that uses data from a sample to draw conclusions about a population. So hypothesis testing is under inferential statistics. So in hypothesis testing, we have null hypothesis and then alternative hypothesis. So, for example, a researcher may wish to know if a new drug will reduce the number of heart attacks in men over 70 years of age. So, for this study, two groups of men over 70 would be selected. One group would be given with a drug or a medicine, and the other would be given a placebo, a substance with no medical benefits or harm. So later, the number of heart attacks occurring in each group of men would be counted. A statistical test would be run and a decision would be made about the effectiveness of the drug. So in this example, you have two groups of respondents. One group of 70 years old men, and this group of men use the medicine for heart attacks or for aiding the heart attacks. While the other group use placebo. So, hindi sila gumagamit ng medicine or drug to cure or to prevent heart attacks. So, after the study, you are going to observe who or what group have a higher number of men with heart attacks. So if it is a group of men who use the medicine, it means that the medicine is not effective. However, if a group of men with who use the medicine has less number of heart attacks, it means that the medicine is effective. So that's it. Thank you so much for um, watching this video or for listening in my discussion, and I hope you learned from this discussion. Thank you so much, and you can comment your suggestions, you can comment your questions, or you can comment additional information in this topic. Thank you so much and goodbye.